In this section, we're going to be looking at factoring special products. So we're going to start by looking at perfect square trinomials. So if you remember from a couple sections ago, we had the form a squared plus 2ab plus b squared equals a plus b times a plus b, which equals a plus b squared. So we're going to look at an example of this now, how to identify this. Let's say we had x squared plus 6x plus 9. If both the first and the last terms are perfect squares, which in this case they are, because the square root of x squared would be x, and 9 would be 3 times 3, and the middle term is 2 times 1 factor from the first term and 1 factor from the last term. So basically, if I took 1, 3, and I took 1x, and I multiplied together, and then I multiplied them by 2, that's basically like doing 2 times ab, as you can see above. So if that works out, and in this case it does, because 3 times x equals 3x times 2 gives us 6x, that means that it is a perfect square trinomial. And if it's a perfect square trinomial, we can just write x plus 3 times x plus 3, so we take 1 factor from the first term and 1 factor from the last term. And then we can just write x plus 3 squared. So let's look at a different perfect square trinomial. If you remember from a few sections ago, we had a squared minus 2ab plus b squared. The only difference now is that there's a minus sign in front of the 2ab, which could be expanded to a minus b times a minus b, which would also equal a minus b squared. So let's look at an example of this. We have x squared minus 2x plus 1. So if both the first and last term are perfect squares, which in this case x squared would be x times x, and plus 1 would be 1 times 1. And now if we took one term of each, if we took 1, and we took 1x, multiplied them together, we would have 1x. And if we multiply by 2, we would get 2x, but we need that negative. So when we're writing out the actual factorization, it would be x minus 1 times x minus 1 equals x minus 1 squared. You know to put the minus sign when the middle term has a negative next to it, and it's a perfect square trinomial. Now, if we wanted to check this, we could FOIL the x minus 1, so we'll go ahead and do that. So x times x gives us x squared, negative 1 times x gives us negative 1x, x times negative 1, another negative 1x, and then negative 1 times negative 1 gives us a positive 1. And if we simplified, we would get the original equation. So now we're going to look at recognizing and factoring the difference of two squares. If you remember from a few sections ago, we had an example of a minus b times a plus b. And when we multiply these together, we ended up with a squared minus b squared. So if we can identify these problems, it'll make factoring a lot easier. So let's look at an example. We have x squared minus 81. If we look at this, we can see that they're both perfect squares. X would be x times x, and then 81 would be 9 times 9. So what we can do is we have x times x plus 9 and x minus 9. So if you can identify that both the first and last term are perfect squares, then you can just simplify it, find out what the square root of each is, and then put them together as x plus 9 and x minus 9. And if we wanted to, we can go ahead and factor this out again. So to show you that it's true, so x times x would be x squared. 9 times x would be positive 9x. X times negative 9 would be negative 9x. And 9 times negative 9 would be negative 81. And the two 9x's in the middle would cancel out, because one's positive, one's negative, leaving us with the original answer of x squared minus 81. So let's look at another example of this. We have 9p to the fourth minus 16q squared. Now, let's look and see if they're both perfect squares. The first term, 9p to the fourth. If we multiplied 3p to the second times 3p to the second, we would end up with 9p to the fourth. So that's a perfect square. Now let's look at the second term, 16q squared. If we did 4q squared times 4q squared, we would end up with 16q squared. Actually, if we did 4q times 4q, not q squared. Now, because they're both perfect squares, we know that it's a difference of two squares. So we can go ahead and set up the same thing as a plus b minus a plus b times a minus b. So it would be a in this case would be the 3p squared plus b, which would be 4q, times a, 3p squared, minus b, which would be 4q.